Hello and welcome to all my young friends who are studying in intermediate and they are watching this video. As I had already indicated in my earlier demo videos that I'll soon be uploading full courses. So today I'm starting that exercise. I got a lot of feedback from you all. In fact, a lot of appreciation from many of you about my initiative, and I thank all of you from the bottom of my heart for that. The good words you said about my initiative. One feedback which I got from a lot of you is that many of the topics which people find a bit scary, like calculus in mathematics and mechanics in physics. So many of you wanted me to give priority to those topics. Hence, I thought it is good to start with calculus in mathematics, followed by mechanics in physics, and one by one, I'll be uploading all the topics till I complete this whole course of intermediate. I'll be uploading every subject in sequence. The videos will be in sequence, and I request all of you to watch each and every video because in every video, some of the important concept is going to be discussed with some good examples so that your concept is further reinforced. So please don't miss any video. So, without wasting much time today, let's start our topic of today, which is calculus. So, let's learn about calculus. Calculus is generally taught in intermediate, and since it's a new subject, many of the students find it a bit difficult to understand. And further, the definitions which are written in books, they are not very easy to understand in the first instance. So people find it again a bit scary. That is the reason a lot of students face problems in this subject. And again, since calculus has its application in other subjects also like physics and even in chemistry, so students start facing problem in those subjects also because of the application of calculus. I have prepared my whole this series, which is calculus made easy, in such a manner that it is very easy for you to understand this subject, which appears a bit complex to you, or complicated, or scary. And I'm pretty confident that once you complete this whole sequence and series, you will be having a good command on this topic. And after that, if you again go and read in your books the definitions, you will be able to understand them very easily. So let's start our topic, calculus. Let's start with a bit of historical perspective. Calculus was invented in 17th century by Sir Isaac Newton and Sir Leibniz. These are very well-known, renowned names. They do not need any introduction. This is Isaac Newton and this is Leibniz. Although there was a bit of controversy at that time that who had actually invented and who was the first, but finally it was decided that both of them independently invented this at the nearly at the same time. But we are not much concerned about this controversy. Rather than we are more interested in learning about the subject. So if you are interested to learn about this controversy, you can just go to Google and find that. So let's learn about calculus. What exactly is calculus? Now, you must have uh, read other topics in mathematics like geometry, algebra. What do you do there? Like in geometry, it deals with the study of shapes. You learn about shapes, straight line, angle, circle, triangle, rectangle, polygons, and so on and so forth. Algebra, it deals with the study of mathematical expressions. Like this is one mathematical expression. These are other examples of mathematical expressions. They can be many number of mathematical expressions or equations, you can call them. Now, what exactly we do in calculus? Calculus deals with the study of continuous change. In calculus, we study change. So, first of all, the first question which comes to mind, what is change and why do we require to study this change? Why do we require to study this change? The answer is, if there is a continuous change in parameters and those parameters are basis of our calculation, then it is essential for us to study this change. For example, if our calculation is x into y, suppose the value of x is 5 and value of y is 6. So our calculation is 5 into 6, that is 30. Pretty simple. Now x is also constant and y is also constant. But if x is changing or y is changing or both are changing, then what do we do? Then we have to study change. How are they changing? Now, following example, which I am going to discuss, they will make it clear as to what do we mean by change. Now, you all know that area of rectangle is length into breadth. This is the dimension of length. This is breadth. So, area is equal to L into B. Now, why is it L into B? Because if you move in this direction, indicated by arrow, this dimension of breadth is constant. You can see. Or if you move in this direction, indicated by this arrow, the dimension of length is constant. That is why area is written as length into breadth. But how do we measure area of circle where both dimensions are changing? If you move in this perpendicular direction, which I had indicated, but you will tell, oh no, we know that area of the circle is pi r square. But how do you find that? Actually, that is found by employing calculus only. Now, if you move in this direction, this dimension is changing. Just see, it's not constant. And if you move in this perpendicular direction indicated by this arrow, this dimension is changing. Or if you have to measure area of figure like this figure is called ellipse. Again, in this direction, this dimension is changing. And in the perpendicular direction, this dimension is changing. So you cannot employ here the formula of length into breadth. Then how do you measure it? Let's take an example of volume. You all know that volume of a cuboid is area of the base into height. Suppose you have a cuboid like this. This is the length of cuboid, this is breadth, and this is height. We all know that the volume is area of the base. Now base I have indicated by a light red color. The area here is L into B. So my volume is equal to L into B. This is area of the base into height. Now, why do we write in this manner? Because if you move in this direction indicated by this arrow, this area remains constant. Here also it is L and B. If you again move L and B. So if you move in this direction of height, the area remains same. But how do we measure the volume of a cone where if this is the base and you move in the direction of height, you see the area is changing. It is getting shorter and shorter. So how do we measure volume here? This is a question. So you will tell, no, we already know the formula, but it is derived from calculus only. That is what we are going to learn in calculus. Another example, a car is traveling with a constant speed s. Now, distance travel, if you want to calculate, that is speed into time. For example, if your car is traveling at 60 kilometer per hour, if you travel for 2 hours, how do you calculate the distance? 60 into 2, 120 kilometer. So what we did here, we had multiplied the speed with time. That is S into T. We have used this formula and calculated the distance. There is one more method of calculating the distance. Uh, Probably you must have read in physics. If we plot the graph between speed and time, in this case, speed is constant, we'll get a straight line like this, because at any time, you take this as T1 or T2, you will see that this component is always S distance. So here speed is constant. So we got a straight line. Now, if we want to calculate distance traveled in T time, say this is a time T, just complete this rectangle. This side is S and this side is T. So area is equal to S into T. So that means the area under this curve represents distance. So even if we plot the graph between time and its speed and we measure the area, that is distance covered. So you can use either of them. Either you can calculate the distance using this formula, or you can use the this kind of graph. Now in this case, the example which we are discussing, the speed is constant. But if there is a variation and the speed is continuously changing like this, it can be in any orbit form. Speed started from zero, it is changing, it reached to a peak, then it started declining, then again it started increasing, then again it started decreasing and it reached zero. It can be in any type of variation. Now how do you do? Now you cannot employ that distance is equal to speed into time. This formula you cannot employ. And even if you want to calculate by drawing the graph and finding the area, how do you calculate this area? This is not a regular shape. So how do we calculate the area under the curve? Now you can see here S is changing. There is a change. That means it is required to study this change. These are some of the example of areas, volume, or speed, time variation. But take one more example from day to day life. Changes in BP. We all know that in the whole daytime our BP changes, blood pressure, and even it changes with age also. So suppose you take a duration of one day from 6 o'clock to next day 6 o'clock and plot the time on x-axis and BP on y-axis, and say these are morning hours. So you will may find variations like this. This is diastolic and this is systolic, the upper BP and the lower BP. Now doctors need to study this change. You can see BP is also not constant, it is changing. So in many of the cases, these changes need to be studied. We all know that there is a weight loss due to corrosion. If you just put a iron rod, if it's, say it's not painted in your in an open area in your house, a thick iron rod, say having 2-3 centimeters of dia and say a length of 2 to 3 meters, and just put it in your lawn and erect it in your lawn, and you see over a period of time, say till 5 to 10 years, you will find after 10 years it will be totally nearly gone. The whole weight will be reduced